Okay, guys, so we're going to go to the first lesson of our notes, and it's about symmetry. Your book does not have a specific lesson on it. It's just a little bit notes because it should have been done last year, but I'm not sure how much you remember from it. So we are going to go over this. So the figure has a symmetry if there is a rigid transformation. Rigid transformation is means that it's going to preserve the length and the shape and the size of the figure. So um, basically, the size will not change after you perform the symmetry. So the three types of rigid transformations are, guys, sorry. Rigid transformations are reflections, rotation, and translation. Okay. Can you read us? I hope so. Okay. So reflection. If you're reflecting something, you need to have a line of symmetry. So line of symmetry is needed. And it's also called mirror symmetry because the line works just like a mirror. And when an object is reflected over it, it's just gonna look like its own image. So the figure will look like its mirror image. So when you are looking in a mirror and you're making faces, the mirror image of you will do exactly the same. Hopefully, if not, you are in a horror movie or something even worse is happening. So what you also can notice that your image is exactly the same length uh, from the mirror as whatever your length you're standing 1 feet away from the mirror, your image will be 1 feet away from the mirror on the other side. Okay, so what we also have to talk about, if this is you, you are called pre-image. Okay, you're pre-image. And if this is your mirror image, we call this image. Okay, so this is you, and this is your image. Okay, so how does it work? Well, if I have some figure and I want to reflect it over my line of reflection line, I have to see how far away is that image from my mirror symmetry, so my line of reflection. And I'm going to try to find the same length on the other side for each point and draw my image. Okay, this is only drawing, so I know it doesn't look exactly the same, but I hope you guys get the point. Okay, how do I know the figure has a reflection symmetry? Okay, does it have reflection symmetry? Well, if I take any figure, I'm going to take the little house that I drew there, and I'm going to draw any line that I can to check if I can find line of symmetry. So, for example, if I draw the line right here in the middle, and I will fold this picture along this line, um, the one side will cover the other side. It would match exactly. Well, my house is kind of crooked, but So if you can find a line that you can fold your picture over that line and it's going to match on both sides, that's how we know it has a reflection symmetry. Now, if I would check this line, it wouldn't work because those two pieces wouldn't cover each other. But some of the figures has not only one reflection of symmetry, so you can find more than one. Okay, rotation symmetry. Rotation symmetry is probably the worst or the most difficult to imagine. So you need three things. You need a point of rotation, which should be given to you. Okay, you should know the degree of rotation. So the most common ones are 90 degrees, 180 degrees, and 270 degrees. Okay, there are different rotations, but we're not gonna deal with this. We're just gonna use the simple ones. And the third thing you need is the direction. So what do I mean by that? Are we going to the right? Are we going clockwise? So just the way the clock works this way. Or are we going counterclockwise? Which means are we going backwards, opposite to the clock? So those three things has to be given to you. For example, this is the simple rotation. I'm going to take my image and I'm going to say this is my point of rotation and I want to rotate it. This is the point of rotation. Okay, I want to rotate it 180 degrees and I'm going to say clockwise. So I'm going to go this direction. Okay, if you think about rotation has to go kind of around the circle. So you would imagine the circle here and then rotated this clockwise, basically would end up, upside down on the other side. That's 180. 90 into 70 are a little bit more complicated. That I'm going to show you in a moment, but that's just as simple. What's the most important is think about the circle and going around the circle. That's a rotation. Okay, how do I know the figure has a rotation? Rotation. How do I know that? Well, so if figure has a rotation, you would check this by trying to either imagine or probably or use a tracing paper, which we're not going to use much this year, but sorry, but you're going to try to rotate the shape up to 360 degrees, so almost a full turn. And at any point, if it matches your pre-image, that means it has a rotation symmetry. So I'm just going to write if it looks the same after some rotation that is less than full turn. So 360 degrees, less than 360 degrees. So for example, this guy, if I keep rotating it over until almost a full turn, I will not ever end up with the same shape because this one is upside down, so it's not the same. So this figure right here does not have a rotation symmetry. It will never look the same after rotation unless I end up at the same place, which is 360, and 360 doesn't really count. So I think rotation are the hardest one to imagine. but we'll work with them. Translation. Translation, otherwise it's called a slide or shift. What do you do really is you move the figure. So you move the figure up or down, right or left, depending on direction. Sometimes there can be a combination of them. So for example, I'm going to have my shape and I want to translate it. Let's say directions are 3 units right and 1 up. So you have combination of it. So I'm going to move it 3 units. Let's say this is my unit 1, 2, 3. So this will be my first step. And then I would move it 1 up. So it would end up somewhere here. Sorry about that. Okay. So let's take a look at some examples. For you this year, guys, because we cannot do a lot of things on the paper, it's going to be just to some of the things you're going to have to do on the computer, but some of them you're just going to have to recognize what type of reflection is it. So for example, if I want to reflect an object, and this is a little bit tricky because there's different line of reflections and we need to know how they look. So first line is going to be my mirror. It's going to be at x-axis. So this line right here, that's why I use a straight edge, right? This is my x-axis, and this is my mirror for this problem. Okay, so I'm gonna pick the point. Let's say I'm gonna pick it. It's kind of hard to see, guys, but they go by 2, so this is 1 and 1. So let's say we're gonna pick a point right here. This is my pre-image point P, and I want to reflect it over x-axis. Okay, what does it mean? That means the image is supposed to end up on the other side of my mirror and exactly the same length. So it's going to be on the same line here because it's not going to move side to side. It's going to be on the other side exactly the same place. So I want to see how far away from the mirror this point is. Well, it's 1, 2 units. So I'm going to count 1, 2 units, and this is my reflection point. If this point is at 1 for x and 2 for y, this point will be 1 for x, because that hasn't changed, but -2 for y. Those are my new coordinates. So what else you have to remember? That if your pre-image is at the top and you're reflecting it over x-axis, your image is going to end up on the bottom of it, right? If you're starting from the bottom, you're going to end up on the top. And it doesn't matter what part of the graph you are. If you're starting on the bottom here, you're going to end up on the top. So that's one line of reflection we're going to be using. The second line of reflection is y-axis. So y-axis is this line right here, right? That's my y-axis, and that is my mirror this time. All right. So if I choose any point, so let's say I'm going to choose, this goes again by 2. So 1, 2, 3. Let's say 3 and 3, 2. This picture is terrible, but let's say this is my point. And it's at x is -2 and y is 3. Okay, I want to reflect it over my line of symmetry, which is x-axis. So this time I'm going to the other side of my mirror, right? So I know my point will end up somewhere on this line, and then I have to figure out where. Well, it's 2 points away from the mirror. This from this side, that means it has to be 2 points away from the mirror on the other side. That is my that's my image of my point P, and it's called P prime. That's how we mark it. What are the coordinates this time? Well, the x value is 2, and the y value is still 3, because that hasn't changed. So what's going to happen? If you're starting from the left and you're using x-axis as your line of symmetry, you're going to end up on the right side. If you're starting from the right, you will end up on the left. All right. Next one, we're going to reflect. Nope, I'm missing a page. Oh, it's on this side. Sorry. Okay, next line is the line of symmetry that is y equals a number. So for example, I want my line of symmetry to be at y equals 3. Okay, where is that line? Well, if you want to graph the line, we sometimes make a table. And what does that tell me? Well, I'm going to choose the points for x. I'm going to choose 1 and negative, 1 and 0, and 1 and positive. And then I'm going to look what y should be. Well, they tell me y is 3. So y is 3 no matter what my x is, right? So it's always 3 for y. I'm not changing y. So if x is negative 1, y is 3. If x is 0, y is 3. If x is 1, y is 3. Y is 3 all the time. Okay, that means I'm going to take a ruler this time. That means my line of symmetry is at y equals 3, and it's that line. Okay, it is horizontal line. At 3 for y. Okay. It's kind of weird because when you think about y, you're always thinking up and down. Actually, when y is a number, that means it's a horizontal line. Okay, so let's pick a point. Let's say this is the point that I want to reflect. This point is at negative 2 for x and at, I don't know if you guys see it, 4 for y. So I want to reflect it over the line. This is my line of symmetry, is horizontal. That means I need to end up on the other side. It's going to be somewhere on this line along wherever P was, just on the other side of it, right? How many units away? It's only 1 unit away from my mirror. So I'm going to move 1 unit away to this direction from my line of symmetry. So I'm going to check my point. My new point coordinates is negative 2 for x, and it's 2 for y. That's my point P prime. So if you're using line of symmetry, y equals a number. When you start on the top, you're going to end up on the bottom. And you start on the bottom, you're going to end up on the top. Right? Okay, I'm going to mark this that it belongs to this problem. Okay, the next one is x is a number. For example, I'm going to say x equals 2. I want to use a line of symmetry where x equals 2. Okay, I can make, this will belong to this problem. Okay, I can make my little table x and y. Now I cannot choose the points for x because why can I choose points for x? X is always 2, no matter what y is. I can choose the points for y now. I'm going to say negative 1, 0, 1. Okay, so that means X is 2 for 0, X is 2 for -1, X is 2 for +1, X is 2 everywhere on this line. Okay, so this is my line of symmetry. This is a line X equals 2. It is vertical. Okay, so if you think about X, it has to go through 2, no matter what Y is. So let's pick a point. Let's say the point is, let's pick that one. So my point here is X value for this point is 0, but Y value for this point is 2. Okay, I need to reflect it over this. So it has to be how many units away from this? 2 units away from my line of symmetry. 2 units away is right here. That's my P prime. And the new coordinates for this point is, this time we're moving 1, 2, 3, 4 for X. So if you're looking for coordinates, you always start from the 0, 0, no matter where your line of symmetry is. 4 for X and 2 for Y. Okay, and then the tricky one. The tricky one is where Y equals X. So if I would make my table to see how my line's going to look like, I can choose, they don't tell me what the numbers are, so I can choose anything for X. I'm going to use -1, 0, 1, and then figure out what Y is. Well, Y is whatever X is, right? If X is -1, Y is -1. If X is 0, Y is 0. If X is 1, Y is 1. Okay, so I'm going to plot those points. 0, 0, right? 1, 1. Sorry, I don't want to mess this up because then it's going to make it a little bit difficult. Sorry, 1, 1, and then -1, -1. Okay, so if you look at this, your points should exactly go through each of those intersections. So 4, 4, 2, 2, 2, 2, -2, -2, -4, -4. Okay, that's the most common one to use, and that one is kind of tricky. So that is my line X, Y equals X. It's like a diagonal line. Okay, let's pick the point. Let's make it okay, let's make it a little bit harder. Let's say it's gonna be -1, and let's make it here. So that point P is actually -1, and if this is 1, this is a 1.5. Okay. All right, how do I do that? How do I reflect it over the line? Well, you can go either way. You can go this way, or you can go this way. But whatever many units this point is from this line, you can count them. So it's 1 unit away, 1 unit away, and a half, right? So 2.5 units. It's kind of like your breaking point. It's supposed to be on the other side, so it's going to end up somewhere here. So I have to use 2.5 units, but this time I'm going down. So 1, 2.5. Okay. It's supposed to create, oh, did I do it right? This is too far. I need to get closer. Oh, I think I got a little bit farther away. This is 1, 2, oh, see, I missed it. This is not my fault. It's supposed to create a little square actually here. If you go around, this also is 2.5 this direction. So no matter which side you're gonna go, you always should go the same length. So if you choose to go to the right, and you have to go down right here. So it's kind of like a breaking point. It breaks your line and goes down. So this new point prime will be, what is it? Positive 1.5 for x and negative 1 for y. So you see they switched. Okay, so if you know that, we can do some reflections, right? Okay, reflection across x-axis. This is my x-axis. So if it's on the top, it's going to end up on the bottom. And point A is right here. So I need to go, how many units away is it? And this time, guys, units are 1 here. Each square is 1. So it's going to be a little bit easier. This one is 1, 2, 3 away. That means it has to be 1, 2, 3 away this direction. This is my A prime. If I'm asking you to put the new points, my suggestion is to put them right away when you find them, because then it's going to get a little bit messy to look for the points when we try to connect everything. So I'm going to say this point right now is 1, 2, 3, 4 for x and negative 3 for y. So it's 4, negative 3, my point A prime. Okay, D. D is 1, 2, 3, 4, 5 units away from line of symmetry. 1, 2, 3, 4, 5. This is where my D prime is. And that point is at, I'm recording, go away. What do you need? Okay, so this point is at 1 for x and negative 5 for y. Okay, next I got M. I'm going to start with M. It doesn't matter what order you guys are going to fill it in, really. I'm start with M. M is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This will be my M prime. And my M prime is this time, this is 0, 0. So that will be negative 1 and negative 5. Okay. And then W is 1, 2, 3, 4. 1, 2, 3, 4. That's W prime. And it's also at negative 1 and negative 4. Negative 1 for x, but negative 4 for y. Okay, connecting. Connecting might get a little complicated. Like, what do I connect here? So look at the image, the pre-image. Pre-image goes from A to D, right? From D to M, and from M to W, and from W to A. Yeah, straight eight again. But that's my image of this figure. Okay, reflection across y equals x. All right, y equals x. Ooh, y equals x is a line that is kind of diagonal going through. Each point has to go through this, right? So I'm going to use my straight edge this time. And how do I do this? Well, like we said before, if this point is 2 units away from the line of symmetry, we got to kind of break it and go down. So this is going to be my new L prime. And new coordinates for that point is, this is from 0, 0, 2 to positive, and we're not moving anything to y, so it's 0 for y. Okay, H. H is 1, 2, no, I'm sorry, 1, 2, 3, 4, 5 units away. So I'm going to go 1, 2, 3, 4, 5 units away from this line. This is my H prime. My H prime is 1, 2, 3 for x and negative 2 for y. Okay, Q. 1, 2, 3. 1, 2, 3. This is my Q. Q prime. And Q prime is in the coordinates will be 1 for x and negative 2 for y. All right, now P. P is the last one. It's only 1 unit away from my line, so it's going to be 1 unit away this direction. Oh my goodness. Okay, so where's P prime for as a coordinates in this? It's going to be 2 units to negative x, so negative 2, and then 1, 2, 3 units in negative direction for y, so negative 3. Now connect it. How do I connect it again? Keep the order of the pre-image. L to H. H to Q. Q to P. P to L. Again, what do I forget to do? Ruler. All right. Next one. Reflection across y equals 2. Okay. So if you remember y equals a number, that means horizontal line, and the horizontal line that's supposed to go through y when it's negative 2. Okay, so I got my horizontal line, y equals 2. Kind of crooked even though I use straight edge. So what happened? My I is actually on the line. So what's going to happen to I prime? Well, I prime is exactly in the same place. Because if you're touching the mirror, right, the image is also touching the mirror. So it's exactly in the same place. The coordinates for that will be 1, 2, 3 in x negative, and we're moving 2 down in y. We're not really moving, the point is there, right, from 0, 0. Okay, so E. E is only 1 point away from my line of symmetry. That means it should be 1 point away on this side. So that's E prime. And E prime is at 1, 2, 3, negative 3 for x, and 1 down. So negative 1. Okay, now x. X is 1, 2, 3 away from the line of symmetry. So 1, 2, 3 away for line of symmetry. This, oh, that's not E. This is X. Okay, so X is, where's X for as a coordinates from 0, 0? It doesn't move anywhere for X, so it's 0. But it goes up 1 for Y, so it's positive 1. And the Q is 1, 2 away from X, from my line of symmetry. That means it has to be 2 points from line of symmetry that way. So we have my Q prime. And Q prime is 2 units away from the coordinate, from the origin, X, and it doesn't move on Y, which is 0. Okay, connecting. I goes with E. All right. E goes with X. Make too many points. X goes with Q, and Q goes with I. Mirror image. Your job most of the time for those problems this year will be just to recognize what type of line do we use and how the image looks. You're not going to probably draw much on it, but you still have to know how it works. Okay, the most difficult, rotation. Let's say we got a point P. This is a given point. You need to have a couple of things given. You need to have a point of rotation, and we are going to use the origin. So the point of rotation is the origin, 0, 0. Okay. And let's say I want to rotate it 90 degrees and I want to rotate it clockwise. So I'm going to go to the right. This one, guys, you will need straight edge, or at least piece of paper that has straight edge. So for example, this one. Okay. Why? Because piece of paper or a ruler has a straight edge over here, a 90-degree angle. So if you're rotating, guys, you have to imagine this is going to be on the circle. Okay, the point has to end up on the circle. If you would create a circle here, the point would end up there. So 90 degree, this is 90-degree angle, hopefully, right? What I'm going to do, if this should go to the middle and 90 degree on the other side, right? Now, if you know anything about circles, the radius is the same at whatever place on the circle, right? If I have a circle, the radius is 1, the radius is 1 here, 1 here, 1, 1, 1, 1, 1. They're all 1, right? The length of the radius will not change. That's the most important property of a circle. So if you have a ruler, you can measure how far away is that point from your point of rotation, right? But if I don't have a ruler, I'm using a paper, well, guess what? I'm going to mark this. And I'm going to do the same thing on the other side. Okay, that is my point, P prime. Now, because we're not exactly precise with this, okay, see if I put my right angle here. Oops, sorry. Right angle here. Actually, I drew the line a little bit crooked, right? My point should end up somewhere exactly on this point right here. But I'm not going to make you be so precise, because if you would do it on the paper, I would show you a different way. But since we're going to do it all on the computer, your job's going just to be kind of see where the point should be. So estimate where the point is located. Okay. So this point prime should be actually at 2, 2. It was at -2, +2. It's going to be at 2, 2. Okay, so it's the point, the pre-image is a -2, 2. The image is at 2, 2. So, okay, so let's say this is a little bit more difficult one. Let's make it at -3 and 2. That's my pre-image, -3, 2. And I also want to rotate around the origin, and I want to rotate it again 90 degrees. And let's make it also clockwise. Okay. So I'm going to use again my 90-degree angle right here. I'm going to try to be more precise this time. Okay, so right there. Okay, how far away is it? So if I use this, right, and I'm going to mark it right here, it should be exactly the same length on the other side. So right here. And I'm going to say this point prime is at 2, 3. Okay, I'm going to estimate a little bit. I'm going to go to the whole numbers. If your point is given as a whole number, and why is it not so accurate? Because my point is drawn by my pen. Okay, we're not using straight edge. We're using the paper, so it kind of bends. So, but you're trying to find the closest point that is like a whole number. If it's whole number, it should end up whole number. And think about the circle. Would that make sense? That is on the circle. Okay, so what do you do if your point, well, let's say is point -2 and 3. Okay, -2, 3. And I want to rotate it this time 180 degrees. And actually 180 degrees, doesn't matter if it go clockwise or counterclockwise, because it really actually going to end up in the same place no matter which way you go. Okay, I can take my either piece of paper or the ruler, and 180 degrees should end up exactly on the opposite side of my point of rotation, which is also origin, 0, 0. We're always going to use the origin. So I would draw my line. Okay. I can see how far away is it. You can measure, or you can use paper. Okay, it is somewhere here. So I'm going to use the same length on the other side. Right here. And it should be, you should be able to like create a rectangle. That's a circle right here. My point prime is 2, -3. Now, doesn't matter which way you rotate. If I rotate 180 clockwise or 180 counterclockwise, I'll still end up in the same point. So if you rotate 180, it doesn't matter which way you go. So sometimes people say, I switched my life 180 degrees, and that is correct. And sometimes I hear I turn my life around 360 degrees. Well, what's going to happen if you turn it 360 degrees? Well, you're going to end up in the same place. So don't say that. If you said you switch your life upside down, that means you turn it 180 degrees. Okay? Okay, I have a point. Let's say we're going to use the same. -2. Now let's use 3, 2. This is my pre-image, 3, 2. This time, again, 0, 0 is my point of rotation. I want to go 270 degrees, and I want to go counterclockwise. All right. So, if you guys can imagine, this is not as hard as it seems. This is 90 degrees, right? This is 180 degrees. So 90 and 90 is 180. If I add another 90, that's going to be this whole turn. It's 270 degrees. What does that mean? That means it's 90 and 90 and 90, right? There's another way of thinking about it. Do you guys see it? How can I get to this point from this point? Well, I can also do something else. Instead of going 270 counterclockwise, I'm sorry, this is clockwise. Clockwise, I can go just 90, but the opposite direction, right? I'm going to end up in the same point. So if you have something like this, I'm supposed to go this way with this point, right? So I'm going to create, you can do it in 2 ways. You can go 3 ways, actually. You can go 3 90 degrees angles from the point. You can go 180 degrees and another 90. right? Or you can just do opposite and go 1 time 90 degrees, but opposite direction to this. So if I said 270 direction counterclockwise, that is the same as 90 degrees clockwise. So I'm going to choose the easiest way to do this instead of making it 3 times 90 degrees the other direction. So instead of going this way, I'm actually want to go this way. So I'm going to use my straight edge again, my right angle here, right? I'm going to connect the point and extend it on the, see, that's why it's not really accurate because I'm not counting the thickness of my pen. Okay, how far is it? Well, right here. So it should be right there. And that is 2 for x, negative 3 for y. So instead of going 270 this way, like a Pac-Man, right? I just want 90 the opposite direction you told me. Okay, so the last one is kind of easy. That is called translation. That's That's the easiest one. So let's say I'm going to create a triangle. I'm going to create a triangle at 0, 2, 3. This print is really bad. 3, 3. Let's say. Okay, and then let's say negative 2, 0. So I have a triangle at 0, 2, negative 3, 3, and negative 2, 0. Now this is translation. Let's say they want me to move the triangle EWG. Let's call it EWG. They want to move it 2 units down and 3 units to the right. Okay. What I'm going to do, I'm going to take each point and move 2 units down. 1, 2. That's going to be the first step. I'm not done with this. It's just like a stop on the way to my destination. And then I need to use 3 steps to the right. 1, 2, 3. That will be my W prime. Okay. Now, after this video, can somebody please mark how many times I said okay? Now, G, I need to go 2 down, 1, 2. So that's my stop. And 1, 2, 3 to the right. That will be my G prime. Same with E. 1, 2, 2 down, that's my stop, and 1, 2, 3 to the right. So that will be my E prime. So then I will connect it. And I should have written the coordinates first because see how messy that is now? Sometimes it's hard to see. But the new coordinates for W prime is 3 for x, 0 for y. G is 1 for x, negative 2 for y, and then 0 for x and 1 for y is for E. Translations are easy. So I want to translate this guy to 5 units down, 4 units to the right. 5 units down. I would take every single point and translate. So I'm going to start with this. 1, 2, 3, 4, 5. Okay, this one. 1, 2, 3, 4, 5. Okay, this one. 1, 2, 3, 4, 5. 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 You kind of see the shape? That should end up over here. That should end up over here. And now I can connect them. That's my image. There's no coordinates, so I don't have to mark them. Okay, this one, guys, if you want to do it, you can do it by yourself. We kind of did the same one here, so I'm going to skip it from the notes. On Google document, there's a link for the video, how the rotation, translation, and reflections are used in making, for example, movies. It's kind of old video, but I know that animated old movies or science fiction movies, really. But the idea of making it is really the same. So if you are interested, watch it. I'm not going to ask you anything about it. I thought it was just cool. All right, I hope this is good. The question also is how many times I said okay. Anybody? Anyone knows? All right, see you guys. I don't know, next time.